So you have looked at this wax paper activity where you're folding to create the parabola using um, that focus and the directrix. So we're going to dive in here into this alternate definition of a parabola. A parabola is that collection of points, so the collection of points that you just created in a plane such that the distance to a fixed point, and that fixed point we call the focus. So here's our focus. It's kind of inside the parabola. To any point on the parabola is equal to the distance from that point on the parabola to the directrix. Okay. So the other important thing that we're going to be talking about is this distance, the focal distance, which is the distance from the focus to the vertex. And that's also equal to the distance from the vertex to the directrix. And we call that focal distance P. So the important part, and that we're going to need, is that distance P is directly related to the dilation. So 1 over 4P is equal to A, that letter that we're used to seeing for our dilation. So what we're going to do here is we're going to go ahead and rearrange this equation to graph the parabola. We're going to label the axis of symmetry, find that focus, and the directrix. So I'm going to look at what I need to complete the square for. I need to complete the square for x because it's the only thing that's squared. So I'm going to add that y and subtract that 12. I'm going to factor out that 2 to complete the square. So the number that completes the square here is 9. But I didn't really add 9. I really added 18 because I had already factored out that 2. So x squared minus 6x plus 9 factors to x minus 3, or x minus 3 squared. And then I have that y plus 6 on the other side. So I'm going to subtract that 6, and I get y equals 2, x minus 3 squared plus 6. So my vertex is at 3. Oh, I had a copy error here. This should be a -6. 3, -6. And then when I graph, I've got a dilation of 2 here. So I'm going to need to dilate those heights by 1. So you can do a transformation table or kind of work here. So I'm going to go to 3, -6. And then the parent function would be these points here, right? But I need to make those 2 times taller. So I'm going to make that first one over to the left one and up 2, and over to the right one and up 2, and then I'm going to go up 8 to get my next set of points. I think that's up 1 too many. There we go. Okay, there we go. So this is 3, -6. So that's my vertex. My focus is somewhere in here, and my directrix is somewhere down here. So we're going to find those. Okay. So 1 over 4p is equal to A, the dilation. 1 over 4p in this case must be equal to 2. So I can go ahead and multiply both sides by 4p. So I'm going to get 1 equals 8p. So p equals an eighth. So what that means, if I go back and look at this picture, and it's kind of hard to see unless I'm zoomed in, the distance here from the vertex to the focus, I'm drawing it much bigger, is 1/8. The same in the other direction to the directrix, also 1/8. So because my vertex is at 3, -6, I can add an eighth to get my focus. So my focus is at 3, -5 7/8. If I write that as an improper fraction, my focus is at 3 and then -47/8. This is a horizontal line, y equals something, but it's going to be -6 minus an eighth, or -6 1/8. So my directrix is at y equals -49/8. So there's my equation of my directrix. There's my focus. I've got my vertex on there. The only thing I think I didn't label here is my axis of symmetry, what goes right down the middle, and that's x equals 3. Okay. All right, let's take a look at this next example. So they give us a directrix. I'm going to start with the directrix, y equals 5. And then the focus is at 2, 3. So 2, 3 is actually down here below the line. That's my focus, which means my vertex is halfway between those. So this total distance, if I look at my y values, is 2, which means that each of those distances is 1. So P equals 1. So 1 over 4 times 1 is equal to A. I need to find my vertex, so I can just add 1 to that y coordinate. So my vertex is at 2, 4. So y equals negative, because I'm facing down, 1/4 x minus 2 squared plus 4. There we go. All right, I'm going to create a sketch for the second one. I've got a directrix at x equals 2 and a vertex at -1, 4. It's my vertex. So my focus would be somewhere here. So my distance from my vertex to my directrix, I'm looking at the x coordinates here, that's 3. So I've got x equals 1 over 4 times 3, and I'm facing to the left, so this is going to be negative. Y minus my y coordinate, which is 4, squared minus 1. Just going to clean this up a little bit. X equals -1/12, y minus 4 squared minus 1. So that's how we can use this focus and directrix to find the equation of a parabola.